Pallet fire in East St. Louis. It has been burning for several hours now.
Fox 2's Chris Regnier is live where firefighters are fighting not only the flames, but these high winds too. Chris?
Definitely a challenge out here this morning. Blair, good morning to you. John, good morning to you as well. We are just off the Poplar Street Bridge here in East St. Louis on South Main Street. Behind us, you can see there is still an active firefight ongoing out here. We see a ladder truck up putting water still on this pallet fire. The smoke has lightened a little bit in the past few minutes, but there is still quite a bit of smoke coming out of the pallet company here. You can also see that orange hue of flames still there as well. Fire crews from all across the metro have been here, continue to be here, trying to contain the flames. But as you might imagine, the wind this morning certainly making this firefight more challenging. I want to show you some video that our Brian Howe captured here overnight when the flames were just raging in this area, embers flying everywhere from the winds, increasing the risk of this fire potentially spreading. Firefighters initially getting the call here about 1:30 this morning. As you might imagine, it did not take long for the products here to go up in intense flames. There are an incredible amount of wood pallets in this area, lots of perfect fuel for an intense fire. An internet search shows this business is called Pallet Sales and Recycling. The company's website saying it delivers durable, sustainable, and customized pallets to various companies. But this morning, the business has simply turned into an inferno. We understand more than 24 different fire departments have responded to the scene here. Authorities have been trucking in water because there appears to be a fairly limited hydrant water supply where this fire is taking place. We can confirm that at least earlier we saw a water tanker come in from as far away as St. Jacob in Madison County. St. Louis City fire crews are also assisting here in some capacity. We are trying to get more details on that as we speak. Fortunately, we have no reports of any injuries. We are reaching out to fire crews at the scene to try and get more details. Those are fairly limited at this point as those crews continue to fight the fire. We will certainly continue to try and get more details, bring those to you just as soon as we can.
So this is just one story, and I chose a pallet fire on purpose because a friend of mine who I talk about in the lecture, who's the Jefferson County fire chief, is you should not keep indoors stacks above 6 feet, I think, of pallets. You might think it's like an ergonomic thing or it could tip and fall, but wood pallets are basically perfect setups for fire. Once it starts, it's really hard to control. Whenever you see, what he had told me once is when you see the ladders just spraying water, it's a complete loss. That building is going to burn to the ground. It's just they're trying to protect or contain it. That's all they're trying to do. They're not trying to fight it anymore. And then I think I had mentioned this too in the lecture that the plastic totes and pallets are actually even more dangerous because once they melt, it turns into gasoline. So I've got actually another video here. This is the Chemical Safety Board. It talks about the Imperial Sugar disaster. I'm just going to start it and play it for a little bit, but I'm not going to play the whole thing. You could watch the rest on your own.
At 7:15 p.m. on February 7th, 2008, a series of violent sugar dust explosions devastated the Imperial Sugar Refinery in Port Wentworth, Georgia, just outside Savannah. Explosions raced through the buildings, fueled by accumulations of combustible sugar dust and sugar that had spilled from equipment. Thick concrete floors heaved up, and brick walls were blown into stairwells and work areas, blocking many exit routes. Fires spread rapidly. 8 workers died at the scene. 6 more died later at a regional burn center. Dozens of others were injured. The plant's massive sugar-packing buildings were a total loss.
The accident at Imperial Sugar was the deadliest industrial dust explosion in the United States in decades. It highlights the extremely serious nature of combustible dust hazards.
There were significant accumulations of sugar dust and spilled granulated sugar on surfaces throughout this facility. Conditions were set for a catastrophic accident.
Imperial Sugar's sprawling Port Wentworth complex began operations in 1917 and grew to become one of the largest sugar refining and packaging facilities in the U.S. Granulated sugar from the refinery was stored in 3 100-foot-tall silos and then conveyed into packing buildings where it was packaged for distribution. Granulated sugar was also converted into specialty products such as brown sugar and powdered sugar. Sugar was transported by a complex system of bucket elevators, screw conveyors, and conveyor belts. During this process, sugar spilled onto floors throughout the work area. In places, the spilled sugar was many inches deep. This sugar also contained fine particles which became airborne. In addition, hammer mills were used to crush the granulated sugar into powdered sugar, creating even more dust. The machines were connected to a dust collection system, but it was undersized and in disrepair. And it was not connected to the bucket elevators and conveyors. Significant amounts of sugar dust escaped into the work areas. Workers routinely used compressed air to clean packaging machines, further dispersing sugar dust throughout the buildings. Over time, large amounts of dust accumulated on elevated, hard-to-clean surfaces, such as ducts, beams, and light fixtures. These surfaces were not cleaned often enough to always keep the dust below hazardous levels. In the tunnel beneath the sugar silos, granulated sugar flowed through chutes onto a long steel conveyor belt. From time to time, clumps of sugar would become stuck in one of the chutes, blocking the flow of sugar on the belt, spilling sugar onto the floor and releasing dust into the tunnel. But the tunnel was large and ventilated, so this airborne dust did not build up to explosive concentrations. However, in 2007, the company enclosed the conveyor belt with stainless steel panels to protect the sugar from possible contamination. The enclosure was not equipped with a dust collection system. As a consequence, sugar dust would now be trapped inside this enclosure. On February 7, 2008, clumps of sugar were found blocking one of the discharge chutes. Sugar from the adjacent silo likely spilled off the moving belt. Dust likely accumulated to an explosive concentration inside the enclosure. At about 7:15 p.m., the sugar dust contacted a nearby ignition source, likely an overheated bearing, and exploded. This primary explosion blew apart the enclosure and vented into the packing building. Accumulated sugar was lofted and ignited by the advancing fireballs. The dust clouds fueled a chain reaction of secondary explosions, which swept through the buildings. Concrete floors buckled, releasing tons of granulated and powdered sugar into the flames. Emergency evacuation drills had not been conducted, and the explosions had cut the power to much of the interior lighting. In the maze of darkened and damaged stairwells and passageways, workers desperately tried to flee the growing inferno.
So I just wanted to give you guys an idea of a dust explosion. It may seem silly to you that sugar would explode, but coffee creamer is actually very explosive as well. Wood dust, if it's really fine. Grain dust, if it's fine. As long as the small particulate can burn, the idea is that If the burning of one particulate can catch the fire of, say, 10 particulate, and then 10 and 10 and 10, the rapid expansion of that, burning or catching of fire of particulate is enough to create a percussion wave that can damage things and look like a fireball. And as the video rightly pointed out, a lot of these dust explosions have a chain reaction. That the first explosion either damages something, that releases something that's flammable or explosive, or kicks up more of the dust, so that there are a series of explosions, and they tend to get worse and worse, and then there tends to be things catch fire then as well. So that's just 2 examples. For this week, I provided more examples, like there's the nightclub fire, Great White, the band from the 80s. There's also West Texas. This was an ammonium nitrate explosion. And I could provide literally dozens, but just giving you an idea, between dust explosion and just regular fires, things like when you stack up things that can burn, it can destroy. So, yeah, and there's a lot of other stuff too. So let's just get to the summary presentation here. I always forget which buttons to hit. Hopefully you guys are enjoying this at least. I hope you guys are. So this week, or this lecture, focusing on both fires and emergency response, but I also threw in there disaster preparedness. The approach you use is pretty much all the same. So we're covering subparts E, subpart L, and NFPA 101, which is the Life Safety Code. If you're a student, in the safety program, you will be taking a fire protection or fire prevention course. If you're a grad student, you have access to it as well. So I don't want to go too far in depth because there's a whole course built around it, but I'm going to at least cover the basics of these 2 standards. And then the other information, I'm sorry, that should have been deleted. That was from the last lecture. So fires and explosions are about 2% of the cause for work-related fatalities, at least in 2023. It's very similar type things, whether you're looking at fires in an office building or an industrial plant. You're trying to identify sources of ignition. You're making sure that you have a detection system and possibly a suppression system, so it's automated, and an alert and an evacuation plan. Fire-related fatalities and injuries. This is just some stats that I got from this is from NFPA, obviously. They show that it's going down. I mean, it's not as prevalent as the other types. But here, home deaths and what's the other one? It doesn't really say. Civilian deaths. Okay, so this is not work-related. This is more home stuff. And then when it comes to disaster preparedness, we just watched a part of a video from the Chemical Safety Board. They do a really good job on following up and analyzing disasters and then publishing on it. But when it comes to weather-related disasters, NOAA, the North, I forget what NOAA stands for now, but it's the weather group. They talk a little bit about the events that cause major costs, cause death. You can also look to both FEMA and Homeland Security for disaster information. So when I was working at that plant a couple of years ago, I was not satisfied with their disaster preparedness. And so I redesigned it. I walked the building. I looked for the safest place for people to hunker down if we had to shelter in place. And I looked for a safer place to muster, the muster point where people are going to meet up, and started putting together plans and drills and put up signage so people knew where to go and when to do it. And then whenever there was a potential weather alert or weather warning or potential weather that was going to be bad, I made sure that there were at least 2 people in the plant who had an app on their phone to let them know if a warning, like a tornado warning, which was very unlikely. I looked through 50 years of weather data, and there had been no tornadoes, though that doesn't mean it couldn't happen. It was unlikely to happen where we were located, but straight line winds was a possibility. And so I planned based on what the potential weather could be and what the potential for fire might be. It was very low, by the way. And what I felt was a greater potential would be maybe a disgruntled employee coming in as an active shooter, or someone from the public entering. And we actually had that happen. A person who was under the influence of drugs climbed up on our loading dock and came in one night, but the night people knew how to take care of him. He was not violent. He was just confused, and they made sure he got the help he needed. I'll just leave it at that. Here's some of the fatalities from disasters. So they don't happen a lot, but when they do, it hurts people, it hurts business. So it doesn't, none of these standards that we're talking about here fall into the top 10. And then there was a lot of them, and I ran them all through. And so the first one was design construction of exit routes. It's over 100, so I covered it, but a little under $700,000. Here is maintenance, safeguards, and operational features for exit routes. So a lot more inspections, a lot more citations, $2.7 million. And then portable fire extinguishers. You can see the numbers right here. And that was it. That was it. We've done other ones where it's higher on the list and everything, and there's been a lot more inspections, citations, and amounts. This one, not as much. It doesn't happen as much. Here's the thing, though. When I was a compliance officer, I defaulted a lot of the fire-related planning and things to the local fire marshal, because most businesses that have brick and mortar are required to have a fire marshal come in, and they're required to probably have property insurance, and then therefore they had a person come walk through. And I let those experts supersede. I was focused on worker injuries. Do they have a plan in place how to evacuate? And that's what I focused on. Or do you have fire extinguishers? Do the workers know how to use them? Are you keeping them available and functional? That was it. There isn't as much information regarding emergency preparedness, but with natural disasters becoming more prevalent, the threat of active shooter, things like that, OSHA doesn't have a specific standard related to it, but they do have information, and they could use the general duty clause if it's something that should have been foreseeable. And so, just as part of your overall risk profile for the company, you should evaluate those sources. As far as evaluations go, I would use fault tree analysis. What is the negative thing? How could it happen here? Trace it back, and then you could maybe control it. And then also visual auditing for ignition sources or accumulated highly flammable material. So one way that certain companies will reduce the likelihood of a disastrous fire is to store things away. So like if you have flammable liquids, we'll cover that next week. You only have a certain amount in a flammable storage cabinet. If you have a flammable storage room, you've got continuous ventilation of 6 air changes per hour. If you can store things outside of your building, away from your building, so if it was to ignite, it wouldn't ignite your building. That's another thing you can do. So there was an ammunitions company, and they had these little outhouses, every 100 feet, and those outhouses had gunpowder in them. You see what I mean? They had it all separate out. So if one was to accidentally ignite, it would only destroy the quantity of that and not affect other things. I had heard that if you go to a Home Depot or a Menards or a Lowe's, that they have spray paint cans in a cage, in a metal mesh cage. And you might think, it's so that people don't steal it. No, it's because if there's a fire, these cans won't become flammable grenades that fly across the plant, that it localizes the fire. That's what I was told by a fire chief. Another thing you can do, one is the visual checklist. You can also use an infrared camera to look for electrical systems that are overheating. I've done that before too. And then you can find out, why is it overheating? Why are we drawing so much current through it? Is it tripping a lot and things like that? And I've actually found that especially when you have a building that people have been adding on, or you add on something that draws a lot of electricity that it normally didn't, things can heat up, and then it can cause an electrical fire because it melts the insulation or reduces the capacity of a safety system to react. So that's what you do. You evaluate what the issues might be. For disaster planning, you may have to look at historical data, whether it's weather related, what sort of other instances or occurrences have occurred within your proximity where you're located, and then plan accordingly. So go ahead and watch the videos, check out the links. This is more of the whole class is built on this. I'm not pretending that I'm going to cover it all, but I want you to make it available. And here's the thing, it also, I think it's important just to keep this stuff in mind. Just and look at it as a comparison to the other stuff we covered. So fire safety, there's stuff here. We've got the standards. Is it going to go to it? Yep. Part E, Part L as well. Hazardous materials is in here, but I put that under a different lecture. Sure, people need to be informed, but the thing is, it happens so infrequently that you should drill on how to evacuate, or drill on how to shelter in place, or drill how to use fire extinguishers. Prepare for emergencies, but then you have to provide, if something does happen, do they know what to do? The initial idea. Do we have people who have extra training and they take over the lead? Do they have the resources they need? Do they need work reminders, like little signage or cards to remind them what to do? Here's the things for emergency response on the OSHA website. Here's just a fact sheet on ignition sources. So you want to see what might ignite. If you've got dust, how are you limiting how it's being released? Are you containing it and cleaning it on a regular basis? If you've got liquids, how are you containing them? What do you do if there's going to be a spill? If you have large containers of a flammable gas, how are you containing it? And if something was to leak, does it release to the outside? If you have so much of a certain chemical that could ignite, do the emergency responders know about it? Is it labeled on the outside? Do you have an emergency or a community response plan? Things like that. Here's the NFPA 101, or the Life Safety Code. Here's a link to the Chemical Safety Board, to FEMA, it's National Oceanic and Atmospheric Administration. They've got good information too. And then you should also be able to put something on your phone or on your computer that alerts you when there might be a weather warning, and then how to respond to it. So I've given you a lot of information. I actually took away one of the lectures. So I took away a 27-minute lecture. So it's this, and then if you want to see these other videos, that other lectures somewhere down here. Oh, it's 26 minutes. Sorry about that. And then I've got some other training videos you can check out too. Fire extinguishers and combustible dust. So that's all I got. Thank you.